Listen closely, for I am about to take you on a journey older than time as you know it, older than mountains, older than forests, older even than the first star to rise in the sky. This is the story of life at its beginning. Close your eyes and let your imagination drift back nearly 4 billion years. The Earth is unrecognizable. Oceans stretch endlessly beneath a faint, pale sun. There are no plants swaying in the wind, no birds cutting through the sky, no mammals padding across the land. The land is barren, the air thin, the sky hazy. But beneath the water's surface, life stirs. Not yet life as we know it, but the very first whispers of what is to come. Tiny spheres, invisible to the naked eye, float and drift, jostled by waves, nudged by currents, forming, splitting, merging. These are the protocells, fragile, ephemeral, yet miraculous. Look closer. Can you see them? Tiny bubbles, membranes forming and reforming, enclosing a watery interior filled with molecules that will one day shape every organism on Earth. They are simple, they are chaotic, and yet, in their simplicity, they hold a secret that will echo through billions of years, the secret of life. Arc 1. Microbial Origins, the Invisible Architects of Life. Episode 1. The Primordial Soup, Protocells. Life's first architects, these first protocells, are astonishingly simple. Their membranes are made of fatty acids, thin but functional, letting some molecules pass through while keeping others contained. Inside, chains of nucleotides, primordial ancestors of RN8 twist and coil. Occasionally, a chain will replicate itself imperfectly, introducing the first sparks of variation. Some protocells cling to mineral surfaces, tiny pioneers staking a claim on the stone floors of the shallow oceans. Others drift freely, carried by the currents. Those that survive are not necessarily the strongest. They are adaptable. They experiment. Some divide successfully, some perish. Some share chemical reactions with neighbors. Some compete for resources. And in this invisible world, life is learning. Every tiny experiment, every chemical reaction is a story being written silent, unseen, yet profound. RNA, the first code of life. At the heart of these protocells, RNA molecules perform miracles. Unlike anything before them, RNA can store information and catalyze reactions, the dual function that makes it the earliest molecular engineer. Some RNA molecules fold into shapes that catalyze reactions, rebuild. They help themselves replicate. Others interact, forming networks. Cooperation begins. Some molecules stabilize their neighbors. Some steal resources. Life has learned, even at a molecular level, the importance of alliances. Imagine a single RNA strand twisting and folding in the darkness of the ocean. It doesn't know it yet, but its actions will determine the course of life for billions of years to come. Every replication is a step forward. Every mutation is a possibility. The rise of microbial mats. Fast forward a few 100 million years. Life is no longer invisible in shallow waters. Filamentous cyanobacteria emerge, the first organisms capable of photosynthesis. Do you see them? Tiny green-brown filaments forming mats that undulate gently with the currents. Layer upon layer, they stack themselves like skyscrapers, creating stromatology for cities of life. Cyanobacteria are remarkable structure, filamentous chains of cells that function, capture sunlight to produce energy. Impact, release oxygen, slowly altering the atmosphere, laying the foundation for future life. Other bacteria swim among them. Heterotrophs consume dissolved organic molecules. Chemalothotrophs oxidize minerals like sulfur and iron, drawing energy from rock itself. Extremophiles colonize hydrothermal vents, enduring heat and acidity that would kill most life. These microbial mats are bustling metropolises, invisible to human eyes. Each organism plays a role. Each interaction matters. Together, they shape the very chemistry of the planet, preparing it for life yet to come. Protists, the first eukaryotes. From these bacterial cities arise the first eukaryotes, cells more complex than anything before. They carry internal compartments, organelles that allow specialized functions. Some drift with flagella, propelling themselves through the water in search of prey. Others ooze along, engulfing bacteria with pseudopodia, digesting them slowly, purposefully. Some eukaryotes are photosynthetic, borrowing genes from bacteria through endosymbiosis. Mitochondria form, producing energy. Chloroplasts evolve, capturing sunlight. Cooperation and innovation are everywhere. Do you see them hunting, drifting, dividing? The first predator-prey relationships form. Life is no longer passive. It is active, ambitious, striving. Microbial ecosystems, cities beneath the waves. The oceans are now alive with microbial civilizations. Biofilms coat rocks, sticky mats of cooperation. Nutrient cycles begin. Carbon, nitrogen, sulfur moving through invisible networks. Predation emerges as protists consume bacteria, and bacteria evolve defenses. Imagine hovering above a microbial mat. You cannot see the individuals with your eyes, but every square centimeter teems with life. The drama is constant. Survival, cooperation, innovation, extinction. And this is only the beginning. Metabolic innovation, life learns chemistry. Even in this microscopic world, evolution drives creativity. Flagella and cilia allow movement, exploration, escape. Spore formation ensures survival under harsh conditions. Quorum sensing lets colonies communicate chemically, coordinating attacks or defenses. Each innovation is a story. Each tiny battle, a drama unfolding beneath the waves. These early microbes are teachers, showing life how to survive and thrive. Cyanobacteria's oxygen revolution. As cyanobacteria multiply, oxygen begins to accumulate in the oceans, eventually seeping into the atmosphere. This great oxidation event will one day allow complex multicellular life to evolve. Imagine standing in the shallow ocean, seeing stromatolite towers rising like green-brown skyscrapers. Oxygen bubbles rise from the mats, changing the very air above. Invisible, yet monumental. The world is beginning to breathe life into itself. Multicellularity emerges. Some microbial colonies begin to specialize. Cells take on roles, protective outer layers, inner cells devoted to nutrient absorption, cells coordinating movement from these tiny divisions of labor. Multicellularity begins a step that will allow organisms to grow bigger, move faster, and conquer land. Preparing for land, by the end of this era, oxygen levels rise, altering the planet's chemistry. Microbial mats enriched sediments, creating soils for plants. Multicellular life and symbiosis set the stage for forests. And now, life is ready for its next great adventure. From the invisible cities beneath the waves, the first green pioneers will crawl onto land. Mosses, liverworts, ferns, they will take the stage, stretching toward the sky. But that is a story for the next chapter. Next episode, Episode 2, Cyanobacteria and Stromatolites, the skyscrapers of the microbial world, oxygenating the planet and setting the stage for life on land. This is HistoPrimordia, where history comes alive. Thanks for watching. Subscribe now and join us for the next episode story.